Hello, I'm Mr. Bob, and welcome to my Algebra 1 review series. This video covers Chapter 3, Section 2, titled Solving Inequalities Using Addition and Subtraction. By the end of this video, you will have reviewed methods for using addition and subtraction for solving inequalities. The solutions reviewed will take the form of and reinforce your knowledge regarding the addition and subtraction property of inequality. Finally, you will review skills for solving a real-world problem involving inequalities. If you'd like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to the channel if you find this video to be at all helpful. Thank you. So before we get started, I'd like to go over a short definition here. An equivalent inequalities. Equivalent inequalities. An equivalent inequality is an inequality with the same solution as another inequality. For example, x plus 4 is less than 7 and x is less than 3 are equivalent inequalities. So I'll read that again. Equivalent inequalities are inequalities with the same solutions. For example, x plus 4 is less than 7 and x less than 3 are equivalent inequalities. Okay, that definition we just looked at, here's where it came from. Equivalent inequalities are equalities with the same solutions. For example, x plus 4 less than 7 and x less than 3 are equivalent. So that there's a pictorial representation to that. So here we see, here's the x plus 4 is less than 7. And you see that we've got the question mark at the top here and 4 boxes. And then on the other side, we have whatever comes out to that is what, 1, 2, 7 boxes. So this question mark is what we're going to apply, right? And they're saying that it's equal to x is less than 3. So that means that if you take away these 4 here that they're showing, these 4, and you take away 4 out of your pile over here, okay, you're going to be left with 3 and the question mark. So the question mark right here is equal to the 3. So they've shown that these are equivalent inequalities. So it says you can add the same value to each side of an inequality, just as you did with an equation. Remember that? We could say, oh, you're going to x plus 5 is equal to 9. You could subtract the same from each side. You could minus 5 from both sides. Or if it was x minus 5 is equal to 9, you could add 5 to both sides. It's the same thing. You can add, subtract, right? From both sides of the inequality, just like an equation. And here is a property that we're going to talk about, the addition property of inequality. For every real number a, b, and c, every real number a, b, and c, if a is greater than b, then a plus c is greater than b plus c. That was like the equals when the equality, we had the same thing with equals. A plus c is equal to b plus c. Remember those when we were doing over those? So if a is less than b, then right here, if a is less than b, then a plus c is less than b plus c. And then they give an example. Example, 3 greater than 1, so 3 plus 2 is greater than 1 plus 2. So 3 is greater than 1, then 3 plus 2 was 5. Is that greater than 3? Yes. Okay, and the same difference. 3 to 1 is a 2 difference. The difference was the change in the 2. How about for the opposite case, less than? Negative 5 is less than 4. So negative 5 plus 2, which is negative 3, is less than 4 plus 2, which is 6. Still less than. It's equivalent. Okay, example 1, using the addition property of inequality. So let's solve this inequality that we've been speaking of for a while now here. It's x minus 3 is less than 5. And they want us to graph the solution. So first we're going to rewrite the inequality. Always, like I say, always rewrite your problem first. That way you know, you look at it, make sure that you fully understand what the problem is saying. You don't want to finish a test and find out that, oh, you thought something was positive or a plus and it was a minus, or a greater than and it was a less than, or something like that. So just make sure that you're working on the same problem that they're asking, okay? So once we do that, then we're going to say, well, we have to get the x by itself, the same as we did with the equations. And in order to do that, we're going to use the addition property of inequality, which means that, so we have x minus 3, we're going to add 3 to both sides. And there it is, the plus 3 both sides. And when we do that, we're going to simplify. The 3's will disappear on the side with the x right here. And we're going to have x less than 5 plus 3 is 8. There's our solution right there. X is less than 8. So now they want us to graph it. Okay, so we can, I left a line here for us to do it, so we can do it now. We're going to draw a 0. I'm just going to put a 0 on here. Here's 0. Okay, here's 8. 8's one of our numbers, huh? 8. How about I'll put a 4 in there? I'll put a 12 in there. How's that? And we'll do a negative 4. So now it says x is less than 8. Well, 8 is our number. Less than means that we're not going to include 8. Our solution has to be less than 8. And the way we do that is we draw, right? We talked about that in the last time. In the last series, we put a circle around the number we're excluding. It's not included. So we put a circle around the 8, and it says x is less. Well, x is everything that you're drawing, right? If there's a line you're going to draw on top of this line, the line you're drawing is the x value. The x values are all contained within that line. And x is less than 8, so that means that 4 is less than 8, right? And 0 is less than 8. So if I go from the 8, I'm going to go everything that's here. Not a very straight line, sorry everyone. Let me do a better job than that. Let me erase that little thing there. What is all that? Let's just start over and see if I can draw. I'll draw from this side. I can draw better. I'm left-handed, so I seem to draw better coming from the left to the right. So there we have it. This is, and it can go on forever. So the fact that I stopped early is, it goes on forever. So here it is, x less than 8. These are the x values. All of these, I'll even put some red in there. All these are the x values. Everything where the red touches. Everything up to but not including what's under the 0. Okay? And if you want to check it, let's say we talked about it, is 4. 4 is under our line right here. 4. 4 is included in our solution. And is 4 less than 8? Yes, 4 is, 0 is, negative 4 is. They're all less than 8. Okay, example 1, check your understanding. So you know what that means. You've been with me now for a while, I hope. If you haven't been, welcome. I'm glad you're with us now. But if you have in the past been with me, you know that I'm going to ask you to pause the video and solve this on your own. And when you come back, we'll do it together. What is the problem? Solve m minus 6 is greater than negative 4. M minus 6 is greater than negative 4. And then graph your solution. Okay, go ahead. I'll wait till you come back. Okay, I'm assuming you've done that and you've worked this out. So let's do it. First thing I'm going to do is draw a line. Okay, put an arrow on each end. Okay, and we're going to write the equation. M minus 6 is greater than negative 4. And we have to get to m by itself. We're going to leave it right where it is. We're going to add 6 using the addition property of inequality. So m minus 6 plus 6 is greater than negative 4 plus 6. When we simplify this, we're going to get rid of the 6's and we're going to have m is greater than negative 4 plus 6 is 2. Greater than. So there's no equals. So I'm going to put down 0 here and I'm going to put 2, negative 2. Here's a negative 2. Here's 2 and here's 4. How's that? So it says m is greater than 2, greater than. So that means that I'm going to change colors. Let's change it to blue. I don't know. Let's try that. So it's not including the blue, the 2, but it's everything greater than. So what we're drawing, the line we're drawing here, are and does represent all the m values. So 4 is an m value, 6 is an m value, a zillion is an m value. And in every case, 4 is greater than 2, 6,000 is greater than 2, but negative 2 down here is not greater than. So, because our line is going off to the right, right? The negative values and 0 down here are not included in our solution. Okay? Okay, objective 1b, it's the second slide in our objective series here, using addition and to solve inequalities. An inequality has an infinite number of solutions, so it is not possible to check all the solutions. We talked about that just recently. Could go up to a zillion, right? Okay. You can check your computations and the direction of the inequality symbol. The steps below show you how to check that x less than 8 describes a solution, okay, to step 1. Step 1, check the computation. See if 8 is a solution to the equation x minus 3, right here, x minus 3 is less than 5. So we write down the original inequality, and then we're going to substitute 8. See if 8 is a solution. I want to know, is 8 a solution? So we're going to put an 8 in where the x was, right here, 8. So now we have 8 minus 3 is equal to 5. So the question is it equal to? You'll see the question mark right there. Is it equal to 5? And the answer is yes, it is. Y-E-S. 5 is equal to 5. So 5 is equal to 5 right here is a solution. Well, for the equals, not less than, but for the equals part. We're just checking to make sure that this is good. So now we're going to check the inequality symbol. Choose any number less than 8. See, here we chose the 8. Now we have to choose numbers less than 8, because if we choose 8, it doesn't work for the inequality. And then substitute that into the original equation right here. X minus 3 is less than 5. So x minus 3 is less than 5. We put something less than 8 in. We're going to put a 7 in. Is 7 minus 3 less than 5? Try substituting 7, right? Here we go. We're trying 7. And we find out that 7 minus 3 is 4, and 4 is definitely less than 5. So this is yes. This is true for the inequality. So that means that numbers less than, you see numbers less than 8 solve this inequality. Since the computation and the direction of the inequality are correct, x minus 3 less than 5 and x less than 8 are equivalent inequalities. So the solution of x minus 3 less than 5 is x less than 8. So we started off with the equation and we got less than 8 when we solved it in the previous step. And we got 8, right? Okay. So there it is. Okay, example 2, solving and checking solutions. Let's solve the inequality 12 is less than or equal to x minus 5. And they want us to check it. So start by rewriting the inequality. Always rewrite it first. Rewriting it and being very careful that you are copying it exactly. And we do this so that we make sure that the question being asked is in our mind. By rewriting it, you're immediately formulating a concept of the problem and how you're going to solve it. And you can make sure that you're solving the problem that you're being asked to solve. One thing you don't want to do is get to the end of your test and find out that you solved the wrong problem. So we'll write the equation or the inequality that we want, and then here it is, 12 is less than or equal to x minus 5. And in order to solve this, we have to get the x by itself. And to do that, we're going to use, since this is a negative 5, we're going to use the addition property of inequality by adding 5 to both sides. And then we can get the x by itself. And when we do that, we're going to clear the 5's on this side because they're going to zero out. And when we simplify 12 plus 5, we're going to get 17 is less than or equal to x. And that's our solution. And to graph it, as you see down here, we have the graph with numbers negative 10, 0, 10, 20. Well, I don't know where 17 was, but as you see, I have a dot. It's a good sized dot, but it's still a dot. and it's on the 17. 17 somewhere down there, okay? It's on the 17. And 17 is included. Why? Because there's a line. It is less than or equal to. So 17 is part of the solution. And x is everything that's greater than 17. It says it. X 17 is less than, which means it's 6x is greater than. So every dot that's underneath this line right here is part of the solution because it says x, and x is all of the dots under this line forever as far as that goes, which it does go forever, right? So it's the inequality says we go off to the right and there's a dot on 17. 17 is included. Okay, example 2, check your understanding. Here's the problem. Solve n minus 7 is less than or equal to negative 2. Graph and check the solution. Okay, so I'll wait for you. Go ahead and pause the video. And when you get back, we'll work it together. Okay, I'm assuming you've done that and you're back. So let's start off by writing our problem. Our problem is n minus 7 is less than or equal to negative 2. Okay, so we have that. So now we're going to do what? Get the n by itself. Here's the n. We have to get it by itself. To do that, we have a negative 7, so we're going to undo the subtraction using addition. And the addition we're going to use is the addition property of inequality. Let's see if I can write it here. Addition, property of inequality. Of inequality. Okay, so when we do that, we're going to get n minus 7 plus 7 is less than or equal to negative 2 plus 7. And when we simplify, we're going to get n is less than or equal to negative 2 plus 7 is 5. There's our solution. So n is less than 5. So then if we put a 5 on the graph right here, and 5 is here, so I can easily put a 0 here. I'll put a negative 5 here. Okay, so now I have those on. I have n is less than 5, so here it is. It's less than or equal to, so I can put a dot because it's equal to the 5, right? And it's also less than, so it's less than. Everything here to the left, all these are all solutions. So negative 5 is a solution to our inequality. 0 is the solution. But up here, 10 is not. Okay, so we've just done everything they've had us do. We've graphed it and checked it because yes, 5, negative 5. If we put a negative 5 in here, if we substitute, we said negative 5 minus 7 is less than or equal to negative 2. Is that true? Well, negative 5 plus negative 7 is negative 12. And is that less than or equal to negative 2? It certainly is. So that solution is correct. Okay, objective 2. Now we're going to use subtraction to solve inequalities. So it says here, you can subtract the same number from each side of an inequality to create an equivalent inequality. And here's our property listing here, this description of the subtraction property of inequality. The last time we had the addition property of inequality. This is the subtraction property of inequality. And it says for every real number a, b, and c, if a is greater than b, then a minus c is equal, or not equal to, is greater than b minus c. And if a is less than b, then a minus c is less than b minus c. It doesn't change if you do the same thing to both sides. So no matter whether you add or subtract, they're telling you here that it's the same. That's what we've learned so far. And examples, 3 greater than negative 1. So 3 minus 2 which is 1, is that greater than -1 minus 2, which is -3? Yes, it is. And -5 is less than 4. So -5 minus 2, which is -7, is that less than 4 minus 2, which is 2? Yes, it is. This property is also true for the less than and greater than or equals, right? Less than or equal or greater than or equal. Okay? Okay, example 3, using the subtraction property of inequality. Solve y plus 5 is less than -7. Y plus 5 is less than -7. So rewrite the equation, the inequality. Y plus 5 is less than -7. Okay, then we're going to say that we're going to use the subtraction property of inequality to undo the plus 5 here with the y, because we need to get the y by itself. So we're going to add a -5 to both sides. So we have y plus 5 minus 5 is less than -7 minus 5. So we're subtracting 5 from both sides. And when we simplify, we're going to get y is less than -12. And that's the answer, the solution here. So is y less than -12 the same as y plus 5 less than -7? So we're going to put it, and this is not including, this is less than, it's not less than or equal. So we have, and 12, -12 is what we said the solution is. So we put our circle around the -12 right here. So circle around -12. And y is less than that. So it's everything to the left. And we already have the line is already drawn in here. It's everything in this direction forever. Okay. And if you put in 20 in here, is 20 less than -12? Oh, sorry, 20's on this side. And the answer is no. But if you put -20, excuse me, if you put -20 in, so -20, is that less than -12? -20 is way down here somewhere. And the answer is yes. Okay. Okay, example 3, check your understanding. It says here, solve t plus 3 is greater than or equal to 8. Graph and check your solution. So I'll go ahead and I'll wait. You pause the video, and when you come back, we'll work it together. Okay, I'm assuming you've done that, so let's take a look at it. First thing we're going to do what is we're going to rewrite the equation or the inequality. It's not an equation, it's an inequality. We're going to rewrite that. And then we make sure that we're solving the correct problem. We have t plus 3. T plus 3 is greater than or equal to 8. Yes. So now, how do we get the t by itself? We get the t by itself by undoing the addition, which placed the 3 here with the t. And to undo addition, you have to use subtraction. So to do that, we're going to subtract 3 from each side using the subtraction property of inequality. Okay? And when you do that, we're going to simplify and we're going to get the t by itself on the left and 8 minus 3 on the right, which is 5. And here it is. T is greater than or equal to 5. So now to graph it, it says it's equal to 5. So I don't have to put a circle. I put the dot. So here's the dot. I got the dot on the graph. And then t, everything that's colored is t. It is the t value. T is any value that can go into that orange line. 6, 7, 12, a million, doesn't matter. It's greater than or equal to 5. Okay, so that we've drawn the line off to the right, and there's our solution. T is greater than or equal to 5. Okay, example 4. It's a real world problem. So a maximum safe load of the chairlift, like the one shown here at the right, is 860 pounds. The weight of the person in the lift, you see the person in there, is 124 pounds. And the weight of the bicycle, also that's in that lift or on that lift, is 32 pounds. How much additional weight can the chairlift safely carry? So it's an inequality because we're going to say it can carry anything up to but it can't go over, right? I mean, it can go up to, but not over. So it's at most it can carry, right? So what do we have? So we're going to relate this problem to words that we can convert into a inequality. So the weight, here it is in the beginning, the weight of the person and the bicycle plus the additional weight that we don't know is at most the safe load. Wait, so what is that? So the weight of the person and the bicycle is 124 plus 32 pounds plus the weight additional, okay, which we don't know that value. We're going to be solving for W. And it is at most, which means it is at most 180 pounds. So it's equal to and less. So it could be anything up to and equal to, but so it's less than, can't be greater than. It's at most 680 pounds. So now we write this in our equation, which is 124 plus 32 plus W, the weight that we don't know, right? There's W, is less than or equal to 680. So you add 124, simplifying that, in the 32 you get 156 plus W plus the unknown weight is still less than or equal to 680 pounds. So now we want to get the W by itself. So in order to do that, we're going to undo this positive, the addition of the 156, and we undo that addition with subtraction. So we're going to use the subtraction property of inequality and subtract 156 from both sides of the equation, not equation, excuse me, inequality. So subtract 156 from this uh, from this side and add it to the original 156, you get 0. So W is less than, that W is remaining, is less than or equal to 680 minus 156, which gives us, after we simplify it, W being less than or equal to 524. So the answer to this question is the chairlift can safely carry an additional 524 pounds. It can carry 523 or 520 or 510 or 400 extra. It just can't carry 525. It can't be over 524. Okay? Okay, example 4, check your understanding. Directions. Your basketball team has a goal to collect at least 160 blankets for a shelter. Team members brought in 42 blankets on Monday and 65 blankets on Wednesday. How many blankets must the team donate on Friday to make or exceed their goal? So I'll go ahead and wait for a little while. I'll let you think about this and solve it on your own. When you come back, we'll work it together. Okay, so your basketball team has a goal to collect 106, at least 160 blankets for a shelter. The team members brought 42 blankets in on Monday and 65 blankets on Wednesday. How many blankets must the team donate on Friday to make or exceed their goal? So what do we do? Blankets. So here we're gonna put the question here, the problem, into words that can be converted into a formula or an inequality. So blankets on Monday plus the blankets on Wednesday plus the blankets on Friday have to equal or exceed, have to be greater than or equal to 160. That's their goal. So I'm going to let M equal 42 and W equal 65. M is for Monday, W is for 65. F is for Friday, the blankets needed on Friday. And when I write the inequality, I get M plus W plus F. So M plus W plus F is greater than or equal to 160. I'm rewriting the equation, the original equation, and we're making an original equation actually. And I'm going to substitute in 42 for M and 65 for W. And we're going to leave the F because that's what we're looking for. So when we do that, we've done the substitution. So now we can simplify. 42 plus 65 is 107. So it's on the left-hand side, it's 107 still plus what's coming in on Friday. And that has to be greater than or equal to 160. Okay, so now we have to get the the Friday by itself. So we're going to use, we have a positive 107. We have to use, to undo the positive, we have to use subtraction. So subtraction, using the subtraction property of inequality, we're going to subtract 107 from both sides of this inequality. Here they are. And when we simplify that, the 107s on the left-hand side will disappear and you'll be left with the F for Friday, which is the number of blankets they're going to need to bring in minimum, the minimum amount to bring in, which is the equal to part, or they could bring in more. And when we do that, 160 minus 107 is 53. So on Friday, the team must bring in or 53 blankets or more. Team needs to donate 53 blankets or more to meet or exceed their goal of 160 blankets. Okay? Good deal.